Hello, math people. So today I would like to go over 2.3, and that is going to be polynomials. So I went over a bit more explanation on why I'm recording these in the 2.2 video, but basically I just wanted to have a few more higher quality videos for you guys to be accessing, just in case you really need it. So our goals for today are going to understand what a polynomial is, to be able to factor polynomials, and to understand multiplicity and end behavior, both graphically and algebraically. So our first definition is what the heck is a polynomial. So a polynomial is a function, f of x, which is going to be equal to a sub n of x to the n plus a sub n minus 1 times x to the n minus 1 plus so on and so forth plus a sub 1 of x to the 1 plus a naught. And this is like way more complicated than it needs to be. It's a super formal definition. Basically, it means any function that you can write like 4x to the fifth minus 3x squared plus 2x minus 5. Anything in those sorts where n is an integer. And so n is called the degree of the polynomial. So if we had like say x squared plus 2, the degree is 2 because n is 2 right there. So then a sub k are all real numbers. So each of these things are real numbers called the coefficients, right? This first one right here is called the leading coefficient, a sub n, and a sub 0 out here is called the constant term. And we'll go over some examples and common pitfalls. So example, let's take x cubed plus 2x squared minus 3x minus 1. So right off the bat, what's our degree? Our degree is going to be the highest integer over here, right? So our degree here is 3. Because we have x cubed as our highest power. What's our leading coefficient, right? So it's going to be whatever is in front of the degree 3 term, right? So that's going to be 1. And our constant term is this thing out here, which is negative 1. Okay, moving on. So now we have negative x to the fifth plus 3x squared minus x. And so right here, we're going to see that our degree is going to be the highest one here, which is 5. So we have a degree 5 polynomial. Our leading coefficient is going to be whatever's in front of that, so that's negative 1. And then our constant term is going to be whatever the constant term is. But there's no constant term here, right? So we have plus 0, and so our constant term is 0. Finally, with this one, our degree is going to be the highest number, integer over here, which is 2. And then our leading coefficient is going to be the number in front of that, so negative 2. And our constant term is going to be 4. All right. So I'm going to go over this quick table of end behavior. So there are basically 4 things to consider with a polynomial. So either the degree is even or the degree is odd. And so when you think of an even degree, think x squared. I think of just parabolas, right? So they're either going to be like this or like this. And if n is odd, then it's going to be like an x term, right? So either a straight line or an x cubed term, like squiggly, right? But it's going to just go to opposite ends when you go to negative or positive infinity. So I like to literally just graph. So if I have like x to the 6th plus 3x squared minus 4x plus 3, I know that the end behavior, because it's an x to the 6th and it's positive out here, is going to be a happy face. And I know that, for example, if we have 3x squared minus 4x cubed plus 2 plus, say, 5x, right here, make sure that you're making sure that the degree that you have is the highest term here. So in this case, it's 3. So that means the degree is odd. So it's going to either be like this, right? So like this or like this. And because this negative 4x is the leading coefficient is negative, it's going to go to negative infinity as we go down, right? So just make sure that you remember these. What I like to remember is if the coefficient is positive, then x increases to infinity means y also increases to positive infinity. And then if an is negative, then as x goes to positive infinity, so to the right, so we see to the right here, it's going to go to positive infinity. And then if an is negative, then as we go to the right, it's going to go to negative infinity. And if it's even, it's just going to be mirrored on the other side. And if it's odd, it's just going to be flipped. And that's shouldn't be too hard. And if it is, just come up to me for questions. So we're going to go over the exact same examples that we had earlier up here. So our example here, so we have an x cubed term, right? So that means it's going to look like this, right? So we're going to have an x cubed term like this. And so when x goes to positive infinity, y also goes to positive infinity. And down here, as x goes to negative infinity, y goes also to negative infinity. In this next graph over here, our degree is odd, and then our leading coefficient is negative. So it's going to be kind of flipped. So it's going to be whoop, 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 whoop. And we see as x goes to positive infinity, y is going to go to negative infinity. And as x goes to negative infinity, y is going to go to positive infinity. And finally, for minus x squared, we have an even function whose leading coefficient is negative, so it's going to be a frown. It's going to go to negative infinity in either direction. So now we're on the topic of factoring, and this is the process of turning a polynomial into a multiplication of smaller polynomials, right? So some common ones are difference of squares, right? So we have 4 equals 2 squared, and negative x, or an x squared equals, well, x squared. So we can factor this as 2 minus x times 2 plus x. But I would prefer x plus 2 times x minus 2, and then just add a negative term in front of here. Take this negative out of here, just because I like to have it x plus or minus something. I like to have positive x. What I like to use for factoring quadratics is called the AC method, and what you do is you multiply a times c and find factors that add up to b. So in this example, we have a times c is 2 times negative 6, which equals negative 12. And let's think of some factors that can lead to positive x, right? So we need to have a pair of factors that multiply to negative 12 and add to positive x. So right off the bat, I'm thinking negative 3 and 4. And then we split up our polynomial into those terms. So we have 2x squared, all right, minus 3x plus 4x, and then minus 6, right? And then I like to factor by grouping at this point. So I consider these two all separate. So we have 2x, or not 2x, we're just going to pull out an x, times 2x minus 3 right here. And then what's the largest factor that we can pull out of here? It's 2. And then inside we'll be left with 2x minus 3. And then we can take out this common term right here, this 2x minus 3. So this is going to equal 2x minus 3 times x plus 2. And that's our factor. Another example is perfect square. So as you see here, x squared is a perfect squared because it's x squared. And then 9 is equal to 3 squared, right? And so if we have our middle coefficient here equal to 2x times 3, which equals 6x, which it does, we can factor into a perfect squares, x plus 3 squared, right? If you guys don't remember this, don't worry about it. You can also use the AC method, right? So if we couldn't do that, we could remember the factors of 9 that add up to 6. So 1 times 9 is 9 still. And the factors that add up to 6 are going to be 3 and 3. And so we have x plus 3 squared. And then another grouping example, I'm going to group them like this. Zoop, zoop, and zoop, zoop. So we have 2x squared, we can take out of here, and then we have x minus 2. And then out here, we can take out a negative 3, and then we'll still be left with x minus 2, right? And then I'm going to make this a bit more clear. So we're adding negative 3 plus 6. Does that sort of make sense? Then we can take out that common term. We have x minus 2, and we're going to be left with 2x squared minus 3. And you could factor this a bit further if you want into a difference of squares, and that's going to look something like x minus 2 times the square root of 2x plus the square root of 3 times the square root of 2x minus the square root of 3, but that's kind of silly. But you will have to use this later, so I will just put that out there now. And then our multiplicity is going to be, this is our last topic, how many times a 0 is factored? So example here, and I'm going to write them out, so starting in order. So 0 is one of the zeros, so x equals 0, has a multiplicity of 2, right, because it's x squared. And then we have x minus 2 squared, so we have x equals 2 as the 0, and the multiplicity is going to equal 2. Now moving on, we have this x plus 3 term, right? But it's just to the first power, right? So we have x equals negative 3 with a multiplicity of 1. Okay, next we have x equals 4 with a multiplicity of 5. And finally, we have x equals negative 2.02 with a multiplicity of 3. All right, so behavior of these multiplicities. So what do these multiplicities even tell us, right? So when we factor, we're able to find the zeros, right? And so the multiplicity is going to tell us how the graph reacts at those 0 points. So if it's an even multiplicity, it like high fives the x-axis. It either touches it, it just touches it, right? Only at that 0, right? But if the multiplicity is odd, it's going to pass through, right? So I like to, again, think of x squared. So it's just going to kiss the x-axis right there. Or x cubed, right? It's going to just go straight through. And I'll use that as use an example here. So first of all, I want to find out the end behavior. So what is our degree here? Degree? Well, that's just going to be the sum of the multiplicities. So we have x squared plus another x squared, or times another x squared, which is going to give us x to the 4th, plus 1, plus 5, plus 3, right? Does that sort of make sense? We're basically seeing, we're just adding up. So if we multiply these out all together by rule of exponents, we would have our maximum term be x squared times x times x to the 5th times x cubed. And that's going to have a power of, if I can do simple addition right, 13. And so this is odd. And since the coefficient outside is positive, it's going to come from negative infinity, right? So I'm going to just copy and paste our zeros and their multiplicities from up here, right? So going back down to this graph, let's look at negative 3 first. It has a multiplicity of 1, which means it's going to go straight through, right? So it's going to look something like this. And then with x equals negative 2.2, our multiplicity is 3. So again, it's odd, so it's going to just go through. When x equals 0, we have a multiplicity of 2. So it's actually just going to touch the x-axis, right? Just going to touch it at that point. With x equals 2, we again have another even, so it's going to go like this. And with x equals 4, we have another odd, so it's going to go like this. So our graph will look something like this. Like, this is very rough, but I hope that gives you a general idea of what to expect. If there are any questions on this unit, please feel free to ask me, and I will post this video on YouTube. Thank you.